Okay, this is 11.5, geometric series. A geometric series is the sum of a geometric sequence. So we dealt with geometric sequences already, but if you were going to find the sum, the formula for this would be to find the nth sum, the sum of the first n terms, would be the first term, and then you would say 1 minus r to the n power over 1 minus r. So you have to remember the formula to be able to figure these out. N is the number of terms you have, or they're asking you for. A sub 1 is your first term, and then R is the common ratio. So when we're looking at the examples, like on this first part, like on number 1, they're telling us find the sum of the first 9 terms. So let's see, that would be sum of the first 9 terms would be our first term, which we see is 2, 1 minus r. Well, you got to figure out what r is. Well, to figure out r in a geometric, and of course it tells us it's geometric, which is really nice, you have to figure out what are they doing from one thing to get to the next. If you don't automatically see it, like here we can tell, oh, it's 5. They're multiplying by 5 each time. But if you don't see it automatically, then take the second term, put it over the first term, and then just divide that out. So, and then this would be, let's see, r to the n power, n is 9, over 1 minus r, which is 5. And then you could put all that in your calculator and get an answer. Sometimes these are a little bit more difficult if, because of the decimals or whatever, and the parentheses and the negatives. It can get a little bit difficult. 97656 okay. So you just have to make sure that you do a few, especially ones like the ones that have fractions in them, to make sure you're getting the right answer and you know how to figure that out. All right, let's look ahead here. Notice on number 4, and I do want to point this out. I'm picking number 4 because it looks to be a little bit complicated, okay? Because we're not doing all of them. We'll do as many as you need to figure it out. But notice here, they want the sum of this sequence. But the problem is we don't know how many terms are in this sequence. So we can figure that out so we can use our formula. So I know that this last term, which is 655.36, is equal to the first term times r n minus 1 times. Okay, so we got to figure out what is r. So that one doesn't look as easy to figure out. So I'm going to go over here and put the second term over the first term. And I can just simplify this or divide it out. And I think you get 0.8. So that's what I'm going to put right here. Okay, so there's my r. I got to figure out what n is. So if I divide by 2500, this is 0.26214. And then I'd have that equal to 0.8 n minus 1 power. Well, remember, when you have an exponent, you need to solve for an exponent, then you do the inverse of exponents, which is the logs. So you can do the natural log or just a regular base 10 log, it doesn't matter. But we do a log of both sides. And then that means we can bring that exponent down, if you remember that property. So this would be n minus 1 times the natural log of 0.8. And now to get n by itself, I can divide by the natural log of 0.8 on both sides. And that's equal to n minus 1. So n would be equal to all of that plus 1. And that turns out to be 7. Okay, so now that I know that there are 7 terms in this sequence, I can use my formula. And I'm just going to change the color to show you that I'm shifting gears here. So the sum of the first 7 terms would be the first term, no, yes it would, 2500 times 1 minus r, and r is, we figured that out to be 0.8, okay, 0.8 to the 7th power over 1 minus 0.8. And that ends up giving us 9878.56. Voila, there it is. So just make sure that you know the formulas and you're able to figure out what piece is missing. So sometimes you have to figure out missing pieces before you can actually use the formula to find what it is they're asking us to find. Now on number 6 and number 5, both of these, they're giving it to us with this whole summation notation. So again, if you just want to use your calculator like we did on the last one and do math 0 and just type it all in exactly like that, you can. I am totally okay with that. That gives you 9,831. If you want to use the formula, you can. You just need to know that what's in the parentheses there that's raised to a power, that is your R. This number right here would be your first term, your first a sub 1. Well, as long as this is 1 and this is n minus 1, that would be your first term. So you should have everything you need, and then the difference between this top number here and this bottom number here would tell us our number of terms here. So our number of terms on the top is 7 on this one. Okay, so on 7 through 10, these are all the same. If you want to just plug it in your calculator, you can. The answers are all on Plus Portal, so you can check those and just make sure you know how to plug it in correctly. As far as these word problems go, they're all basically using the same formula because they're all geometric, because that's the section we're looking at. If it was mixed up, you just need to know which formula goes with which one. Sometimes you're looking for the sum, sometimes you're looking for n. You may not be looking for the same thing each time. So on number 11, it says the grocery store raised money. First month was $4,000, and then they raised 1.5% more than the previous month. So, and they want 4 years. Okay, so the sum of the first 4 years, because total's here, so I know it's sum. 4 years, and this is by months, so that would be what, 48? Yeah, 4 years is 48 months. So first term is 4,000. And then we have 1 minus R. Well, if they're raising 1.4% more than the previous month, this would be 1.015 is your R. If it was depreciating and going smaller, we would say 1 minus whatever the percent was. And then this is, N is 48 over 1 minus 1.015. So that gives us a lot of money here. Now if it's money, make it look like money. Go to 2 places after the decimal and all that good stuff. Okay, so number 12, let's see, they invested $12,000. Expected annual return of 7%. What's the balance in the account at the beginning of the 30th year? Okay, so that would be the sum. We're assuming not taking any out, obviously. The sum of 30 years would be the first one. Okay, 1 minus R. R is 7%, and it's increasing, so this would be 1.07. That is 30 over 1 minus 1.07. And that's a lot of money too. There we go. So again, make it look like money. Now number 13 is a little bit different because Carol wants to be a millionaire and they want to know how long is it going to take it. How many days take her to save $1 million? So this one, I know what my sum is. My sum is supposed to be $1 million. But I need to know how long. So really, I'm looking for n here. So this one's going to be a little bit different. Same formula, though. So I have $1 million equal to n divided by 2. We don't know what n is, but that's not it. That one is, I'm sorry, that's the one for, I'm thinking arithmetic. It's not arithmetic. How do I know that? Well, 1, it's in the geometric one. 2, notice that if they start with 1 cent, and then they're going to 2 cents, and then the 4 cents, they are doubling it each time. So they're multiplying by 2 on each one of these terms. So you've got to use the geometric formula here. So the first term is a penny. Make it look like a penny. Okay, 1 minus R is 2. And n, we don't know how many times, over 1 minus 2. Okay, so let's solve this equation. This looks like it'll be a little bit more challenging than some. 1 minus 2, well, I know this is just -1, so I'm going to just rewrite that as -1. So I'm going to multiply by -1 on both sides to go ahead and just get rid of that denominator. 1 minus 2 to the n. Okay. And then I'm going to divide by 0.01. So that actually makes this a little bit larger of a number. Well, barring it being negative. But anyway, okay, now subtract 1. All right, divide by, go up here, I'm running out of room. Divide by a negative, because there's no reason to have a negative on both sides, because they'll go away. All right, so now to get that variable down off the exponent, I got to do the log on both sides. So I'm going to do the natural log on both sides. Now that variable can come down. And to get n by itself, I'm dividing by ln2, natural log of 2. And that is not a nice pretty whole number, but I think it's like 26.58. So, oh my goodness, if they actually save double what they were saving, and starting with a penny, in less than 27 days, they'll have $1 million. Wow, that's impressive. Alrighty, we are done. Okay, so on the infinite geometric series, if it goes on forever, like these do, as you can tell, because it's got the little the 3 dots there, it goes on forever. Sometimes there is a sum, and sometimes it's not. So if you notice these with the fractions are getting smaller and smaller and smaller. So this actually ends up being a convergent series, and it approaches a certain number, basically, a certain sum. This one actually approaches 1, and I'm going to show you why in just a sec. Whereas on this other one, you see how these numbers just keep larger and larger and larger? This is one that does not have a certain sum. It's divergent. So this one in particular is actually just a growing infinitely amount, like it's just approaching infinity. So you would say that one has no sum and it's divergent. So notice back to the first one here. If we just have the first one, I know I have 1/2, which I'm going to write as a decimal, 0.5. The sum of the first 2 would be 0.75. The sum of the first 3 is 0.875. The sum of the first 4 is 0.9375. So notice how these are getting closer and closer to 1. The more numbers that we start adding in, it's getting closer and closer to 1. It's converging on 1. Whereas if I add the first term over here, I still start with 0.5, but notice what happens when I start adding these values. It jumps up crazy, like a lot. They're not getting closer and closer to one certain number. They're just getting bigger. So it's going to steadily get larger, and it's not approaching any number in particular. So that one has no sum. So how can you tell if it has a sum or not when you're looking at the infinite ones? You have to look at the r. If the absolute value of r is less than 1, then that's the convergent ones. It has a sum. And I'll show you how to figure out what it is in just a bit, because that's the formula for that, of course. If the absolute value of r is greater than 1, then it's divergent and it has no sum, and you don't even have to worry about it. But you need to know when it does and when it doesn't. So the formula, if it is convergent, is, let's see, the first term times 1 over 1 minus r. This is the formula. So you only use this if it's infinite. Okay, so if you have the infinite series, that's when this comes to play, and then you only use it if the absolute value of r is less than 1. So let's see how these look. Here's some examples. So notice on number 13, this one, they are multiplying by -6. So r is -6. Well, this is divergent. It has no sum because the absolute value of r is greater than 1. Okay, that number is too big. Notice on number 14, here they are multiplying by what? What is that, 1/3? Yes, because they're dividing by 3 each time. So this one is convergent, which means it actually has a sum. So I'm going to use the formula. The sum would be the first term, which is 72, over 1 minus r, and that gives us 108. So make sure you know how to plug that in your calculator correctly and get the correct answer there. So again, you're just looking to see, does it have 1? Does it not? So this one, they're multiplying by -1/2. So this one does. This is yes. So that sum would be -180, 1 over 1 minus -1/2, and you get -120. So this one is convergent. Whereas on number 16, they're multiplying by 5/4. Well, that's a fraction, but the absolute value r here is greater than 1 because this is 1 1/4. So it's divergent. It does not have a sum. So just be careful on those. Now, when you get to these, all the other ones we did with the summation notation was really nice, that we were able to just plug that in our calculator and not worry about it really. But because these have the infinity, if you notice, and all 4 of them they do, then we can't just simply plug it in our calculator. So we've got to use our rules and figure it out. We know this is geometric because it has the variable as the exponent. So essentially I'm looking at r, and that is your r, okay? So if that is less than 1, which this one is, then yes, it does have a sum. So the sum would be the first term, which we know is 224, because that's your first term that's in front there. And this would be 1 over 1 minus 3/4. And that should give you 896. On this one, let's see, that is r, because it has the exponent, and that has a sum also because that's less than 1. The absolute value is less than 1. So your sum is the first term, 1 over 1 minus a -0.2, and I think you get 37.5. Number 19, 7, 6, that's your r, but that's too big. It's greater than 1, so it's divergent, so no sum here. This is 1/2, that's your r, so yes, it's convergent. It has a sum, first term times 1 over 1 minus a half, and you should get -16/5. So just double check those numbers and make sure you know how to plug that in your calculator.